Okay, so there will be two parts on the test. You're gonna have to like describe what the transformations actually are, right? And then you have to actually move the graph around, okay? And I'll agree, some of this stuff at the bottom was a little hard to find, particularly the x-intercepts. Okay, they're not gonna be nice. They're just looking for kind of a guess in that instance. I might delete that from the test altogether. I would probably leave the y-intercept and the vertex though. Okay, so I want you guys to like highlight that stuff. Okay, we'll do that in a sec. But let's just go up to the top here. Okay. All you're doing is looking left to right. Okay. So in the red, if I see a number that's between 0 and 1, like if I see a fraction that works out to like when I divide it, it's between 0 and 1, it's compression. Okay, so, and it's, you guys aren't doing anything except the vertical compressions right now. Grade 11, you'll do some horizontal ones. But all you have to write, if you see that fraction up front for the A value, you know it has to be a vertical, either stretch or compression. In this case, it's a compression because the A value is a half. So it's a vertical compression by a factor of 1/2. Okay? Now, the second thing you're going to look at here is, anybody have any questions of that? Okay? If the number's bigger than 1, it's no longer compression. You're stretching it. You're making it bigger, right? Because you all like the number's bigger than 1. So it's just going to get bigger. Okay? What's the second part? I see this piece here. Okay? What does that do? Do I see any brackets? That's your first question. If you don't see brackets, it's the k value on the end, vertex form, right? If I write this in, like if I write the general vertex form up here, y equals a x minus h squared plus k, k is this number on the end. Because I don't see any brackets. Because it's not going to move left or right unless you see brackets, right? So you're going to say, okay, it's a vertical translation up 4 units. Okay, and I'm not even like particularly stuck. This is just the language that I use, right? Miss Farahani probably uses something very similar because that's what's in the textbook. And she wrote some of the textbook. So that's probably her lingo, right? For your purposes, I just want you to know, like, do we stretch, compress? Do we, like, if you use slide right now, I'm not too picky on it. Like, all that matters is that you guys know how to move the thing, right? And what each piece is doing. That's what matters, right? Does that make sense? Don't get too caught up on the terminology. I just want you, the more important part is that we're able to actually visually move the graph around, okay? We can hit you with the terminology later. Like, the fundamentals don't change in grade 11 of what's going on. We can just change the terminology later, okay? So that's 2 marks right there, right? You got 2 transformations there. One's a compression, one's a translation up 4 units, okay? Then we go over to the other side here. Okay, I see a few different things. I always start on the left, you'll notice. Always start on the left like a book and just read left to right. What's there? The negative implies, I can't write in yellow because you guys won't be able to see it, but a reflection in the x-axis, right? Then you go to the next thing. What's the next thing? Well, it's the 3, right? We're gonna, it's a number bigger than 1, so we're gonna vertically stretch okay? Then I'm going to The next thing, we'll do it in blue. I see brackets this time. Okay? Brackets means that there's an H value, it moves left or right. Okay? Which way am I going? Left or right? Remember, it's always opposite to what you see. So I see a -2 there, I'm going to go to the right. So it's a horizontal. This is the only time you're ever going to write horizontal on your page right now, is if you see this H value. Everything else is vertical. Okay, so it's a horizontal translation, or slide, or move, or whatever. Talking as I'm writing. Right 2 units. And what's the last one? The last one is what it is. It's outside of the brackets. There's nothing funny going on. If you see a -2, it implies it moves down 2 vertically. You can see I even have some subtle variances in like the way that I write these things, right? It's not the biggest part of the problem. Okay, you just got to tell me what's going on in your head. Is it okay? There's 6 marks there. 1 for each translation. All I do is read them off, left to right, like a book, one at a time. This is as hard as it's going to get. If you could do this question, like I physically cannot make this any harder on the test than right here. I don't know how else to explain it. It just is. That's as hard as it's going to get. That's got 4 transformations there. For your purposes, that's as hard as it's getting. Okay? So if you can do that one, you can do the one on the left, because there's only 2 there. Right? So probably 2 questions. There'd probably be 2 questions like this, and then 2 graph questions on the test. Okay? I'll just build up the quiz to be the test, basically. Okay? All right. Here's the fundamental issue I had with this question. Right off the bat, I wanted everybody to graph the base graph right off the bat. That's a mark on both these questions. So you go here, you go. Right? I showed you how to produce those. What I will probably do on the test tomorrow is not allow you to have a calculator for this section, just to prep you. Why? Because I don't want people going like this. And just plugging values in. I don't want that. That's a way, yeah, Paul?
Is it like no calculator just for this section?
Just for this part, yeah.
How would you know
What they typically do here is there's no staple on the test. So they give you 1 page, and then like that'll probably be the first page or something. You hand in the first page, and then then you're good to go. I give you the second one. Okay. That's how it operates when you take grade 11 math here. Even the grade 12. That's how they get you without the calculator. Okay, because I don't want people sitting here plugging in. That's not the point, right? I've run into that in the past. And then people get the wrong, like, you can get decimal numbers as the graphs get more complicated, and then it's a nightmare. Okay, if you follow the rules I'm giving you, it's faster. Like, we could do this question in 2 seconds, like 2 minutes here, not even. Okay, so there's a mark each for graphing the base graph, right? And the second one here, now let's actually just do the transformations. Okay, so we're just going to move this around. Same thing as the top though. I'm going to start on the left. You always have to start on the left. Start here and read to the right. The first thing it tells me to do is reflect this graph. Right? So let's do that. I'll reflect the graph. It's still at 0. This point here reflects to here. That reflects to there. And I'm 4 away from the x-axis there. So I'm going to go 4 away down here. Right? Same thing here. 4 away. 4 away. Okay? You can draw the graph. Don't forget your arrowheads, because that implies that they go on forever. Okay? Next. That takes care of the reflection. Now I see some horizontal brackets. That means left and right. Which direction am I going to move? I see a negative. It always goes opposite. So I'm going to go right this time. Right? So I'm going to take every point and I'm going to move it to the right 3. Every point. So start at the origin, go 1, 2, 3. There's a point. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. That takes care of that. One more. Let's move the whole thing up 2. All the points. 1, 2. 1, 2. 1, 2. There you go. The purple one is the final graph. That could be a little bit more accurate with that other arm there. Okay? That's the graph in purple. If I highlight it. Is there any questions? I still have a little bit more to do here, but does anybody have any questions of what I did? The perplexing part for me is when we start seeing funny things go on. Like, if we just follow, it's the same thing as completing the square. I gave you a process with completing the square. It looks great on this quiz. Everybody. Like, I don't think anybody got less than 7 so far. Looks great. This is a process. Just follow it. Right, left to right. And then we'll write down the rules again on the back side so that you have them. But you know what does what, right? That's the other important part, okay? Does anybody have any questions for that one? I still have to do a couple other things here, but I'd like to address, let's address 3 here for a second. Just because that's the part that everybody's kind of not doing so well on the completing the square piece. Does this parabola open up or down? The purple one, does it open up or down? The final graph. It opens down. So if it opens down, how do I know it opens down? The negative out front. Right? The negative tells me it's opening down. So if a parabola opens down, what must it have? A maximum or a minimum? It has a maximum, right? So we know it has to have a max. Okay, where does the max occur? It's a max at +2. What's the x value when the maximum occurs? Careful. +3, yeah. Okay? When x equals 3. Right? So you could write the vertex be 3, 2. Right? That takes care of a part in number 2 there. The vertex. We've taken care of that now. Right? The only other thing you got to figure out, I'm not going to ask you the x-intercepts because it's too hard for me to come up with nice questions. Right? But I can ask you the y-intercept always. Okay? How do we figure out the y-intercept? And why would I care about the y-intercept? I know what the answer is because we've already done this, but we have an axis of symmetry here, don't we? If I find any other point on the graph relative to a parabola, I know it has to be symmetrical on the other side. Right? So if I find the y-intercept here, it's 1, 2, 3 away from the axis of symmetry. I now know another point on the other half of the graph for doing absolutely nothing. Right? 1, 2, 3. It should be right there. I've done no work aside, no additional work to find 2 points. Get 2 points with half the work. You know what I mean? So how do we find the y-intercept? What's the x value along here? Can anybody tell me? What's the x value? 0. So if I plug in x equals 0 into the equation, I should get out a y value, specifically the y-intercept, where it crosses the y-axis. So let's just do that. Y equals, what's the equation? Negative 0 minus 3 plus 2. So y equals negative 3 squared plus 2. There you go. There's your y-intercept. That's 7. Right there. Negative 7, sorry. Okay. There's your 5 marks. Okay, I'll be a little bit more strict with on the test about like what's where and like the stating the y-intercept and whatnot. I was a little bit more concerned with the graph on that quiz. That's where a predominant number of the marks came from. Okay. Again, it's just follow the rules left to right. Okay. And I'll give you a rule chart. I'll write those rules out again so that you have them after we finish this. Okay. Does anybody have any questions? Is it okay? Okay. Again, like there's honestly like I can only make these so hard. Like there's not a lot. Like I can't. There's not another level with these. I only make them so hard. All right. Let's do the next one. 1 mark for the base graph right off the top. Okay. Make sure you draw your base graph. That's a mark right off the top because I've explicitly asked for it in the question. Okay. From there, you can do the transformations that you see, right? Starting at the left, what do I see? I see a 2. What am I going to do? I'm going to multiply all. This is a vertical stretch. So I'm going to pull on the graph from the top, right? By a factor of 2. So everything's going to go up, like get stretched by a factor of 2. Okay, so here we go. If I'm 1 away here and I multiply by 2, then it should go 2 away on the next point. Okay? I'm not physically moving the points anywhere because I'm going to do the same thing here. I'm going to take 0 times 2. Well, it's still 0. Right? I'm not moving the graph physically up. I'm pulling on it and staying stationary. It's like fixed at this point. Okay, there's like a nail in it or something and I'm pulling on it. Okay, it's not moving up, it's just getting pulled on. Okay, and we're stretching it out like silly putty or something. Right? Same thing's true over here, okay? I see I'm 1 away, I'm going to go to 2. Now this one here is 4 away. 1, 2, 3, 4. So if I multiply 4 by 2, it's going to go to 8. That's 9. Okay? Same thing on the other side. There's a point there. It's going to go to 8 also. Okay? There you go. There's the first one. Done. What's the rest of it say to do? What's this say? I see brackets. That means horizontal. Horizontal is always opposite. What do I see there? A +1. Okay, well that means I got to move it left 1. All right. Okay, so I'm going to move it left 1. All the points. 1, 1, 1. The only thing I might do on the test is make them like a little bit further apart in terms of the transformation so you get clearer pictures. Okay, so I might just increase the difference between these numbers is all, so that they end up in completely different areas so you can have nice pictures and there's no crossover. Okay, that takes care of that, and then there's only one piece left. What's the last piece? The -3. So I just got to move all those points down 3. We'll do it in purple again, okay? 1, 2, 3. 3. 3. And then 1, 2, 3. Okay, there's your purple graph. Yes, Fred?
When doing this on the test, do we need to show all 4? Or do we just do first and final?
You can do first and final, yeah. I always recommend, like, most people don't have the issue doing these two at the same time. Most people have an issue with, like, doing all 3. And as they get more complicated, like, I can add 4 or 5 transformations. When you guys get to grade 11, you can have 4 or 5 transformations. So just sometimes a good practice just to do a couple individually. But I'm 100% okay, like, with, if you can do them all, it is what it is. The issue I have with that is if you make a mistake and your graph is completely off, I don't know what to do in that instance, right? Like, I don't know if you actually know what's going on. If you do them individually and you move it up 3 instead of down 3 or something, right, at the very end, then I can see I can see all the intermittent steps. You know what I mean? Not that more work is always better, but it's there. You know what I mean? If something goes wrong, I can see what you've done. Does that make sense? Okay. That's your final graph. Just do it one piece at a time, and then now we're able to state what the vertex is. So let's do that. The vertex is right here. It's at -1, -3. Okay? The parabola opens up. Right? Which must mean it has a minimum this time. Okay? And it's a minimum of -3 when x equals -1. Okay? So we've taken care of the vertex again. We stated the maximum value. The last thing is just find the y-intercept. This one's easy because you can read it right off the graph, but we can prove it the same way. Okay? It's 2 times 0 plus 1 squared minus 3. So I get y equals 2 times 1 minus 3. So y equals 2 minus 3. There's your y-intercept. That checks out with your graph right there. Okay. It's very like sequential. If you guys just follow this, it's not crazy. I would argue that this is easier than completing the square. Less steps or funny business going on with the z value and whatnot, right? You guys can just follow this. It's like reading it as a book. You just have to know what the words are, I guess, right? Coco.
So when you're turning your like points into like the y equals stuff, where do you get the 0 from?
I picked the 0 because the y-intercept. The y-intercept, where would it cross the y-axis? The y-axis is here, right? So if I'm interested in where it crosses the y-axis, what's the x value of that point that I drew on there? What is that? 0. So if I plug in 0 into the equation, it's going to spit out a y value that corresponds with that value. Turns out that it's -1. That's what you call a y-intercept when x equals 0. What value comes out when you plug x equals 0 in? Okay? Is that okay? We've done that a few times. Like, you could produce the graph from just plugging in points, right? But okay. Last one. Okay. I think everybody did pretty good on this. I just missed the last part, which is maybe my fault, but we did enough of them where we talked about why it was linear or quadratic, right? No, but it's implied. Like, we did 10 questions.
You can't expect us to just know what you're implying. You need to write it.
I can when we do it 10 times in class.
We're just gonna do what the question says, though.
No, you do what we do in class.
It says something in the question, you have to do something extra.
Because I told you to during classwork, which you may or may not have been here for. I don't know. It's the little things. If you want 100 in this course, you have to do all the little things. I'm not going to spell it out for you every single time, right? There are things that we do in this classroom, on the walls, the things that we talk about, right? If you want 100%, it's everything, right? I'm pretty sure Ms. Farahani wouldn't specify, explain why. It's just kind of implied. I will put the explain why on the test. Right? We explained why. We went through all those modeling questions and we explained why. Every single time it was linear versus quadratic. Every single time. Right? Because the first difference is matched. Because the second difference is matched. That's all we're looking for. Right? So, 4 to 7, these are the first differences. Right? 3, 5, 7, 9. Okay? Those don't match. Okay? So you got to go again. So we call second differences. The second differences are all 2, 2, 2. You say, therefore, we know okay? Any issues with that one? Okay, there's just your 3 marks there. Okay.